Okay, good morning. So today I just want to actually present more interesting problems on the topic of rational expressions. That would be the last session that we discuss about this. Okay, so I would prefer to write the problems for you, wait for you a little bit so that you can try them yourself first, and then I will come back and help you to solve them. Hopefully, if you have more time, we can actually give more examples. Okay, so these are the combinations. So for example, here I have subtraction, here I have addition and subtraction, but here I have addition, subtraction with multiplication. Here addition, subtraction, and then division. Okay, so I just want you to see that we can mix the problem a little bit from different perspectives, and still we can solve and simplify. So that's actually a very important skill I want you to improve, so that you can simplify algebraic expressions quite extensively. Okay? Okay, do you have any answer for the first one? Okay, the first one shouldn't be that hard. If that's taking so long, might be you're on the wrong track. So let me just refresh your memory a little bit. So if you want to solve that problem, so what is the first step that you do if you want to solve such a hard problem? Yeah? Yeah, because it is important to realize, although it's a little bit deviation from the recipe that I told you before, I just told you that factorize the denominators. Yes? But you always have to be observant and smart, actually. So it doesn't mean that you have to follow exactly those rigid rules. So here, it would be better not only factorize the denominators, but also think about the numerators. The reason is that this fraction on its own can be simplified. Do you know what is this? The situation is like that. For example, if I tell you 7 over 28, and then add it plus 25 over 100. If I ask you to do this, there is no problem if you simplify these two first and then continue. Yes, because here you can just simply write 1/4, and then here the 1/4, and then in a matter of seconds you see 1/2. Okay, so that is also I know that this is usually in numbers it is easy to detect, but it's a little bit different here. So that's the point here. So if you want, I can make a little bit more. So now this problem is more or less like this. So try to simplify this on its own. If possible, simplify this on its own. And then after you have the simplified versions, try to add them or subtract them here in this case. I don't think it is hard. So I just want to wait a little bit more so that you can do it yourself, okay? Yes? Do you have a question?
Answer, yeah.
So what's the answer?
I got b squared minus a squared over ab minus b squared.
Oh, you cannot simplify more than that?
I don't want to say definitely, but I couldn't.
Okay. So what is your answer, Bud?
A plus B over B.
A plus B over B probably is more simpler, yes. So let us see how it goes. I think it is correct. So what you do for the first one, so you realize what to do. So the strategy is a little bit different. So what you do, you take A out from the numerator, and then you can take A out from the denominator. Of course, factorizing the denominator is always the case, but it was not usually the case that you also have to factorize the numerator. So that is occasionally happens. Okay, so if you can observe that, you can get rid of this A. Okay, and then what you can do in the second one, what can you do for the denominator is clear. So I can pull a B out. So A squared minus B squared is left. But what can I do for the numerator? Yeah, because I told you the priority is, if possible, to factor something out from all the terms, so I can pull A out here. And then what happens? This becomes A squared plus 2AB plus B squared. Okay, so then if you want to continue, here I can simplify this with that. But no simplification is possible anymore. So I have to write it down. So if you don't mind, let me write it here. This becomes a plus b over a minus b. And then here I have minus. So this, hopefully you see the pattern here. This is a plus b to power 2. But this is not still fully factorized. So it is b times a minus b times a plus b. That's a conjugate pattern. Of course, you can immediately start taking the common denominator, but this is not recommended because the second fraction itself can be simplified, yes? So why should we do this right now? So I copy and paste the first part, and then I simplify one of these with one of these, so it becomes minus a times a plus b, and then in the denominator I have b and a minus b. So I hope that you agree it is much simpler to subtract these two rather than those two, okay? So then what is the common denominator? So what is the common denominator here? Is b times a minus b. So the second one will play the role of the common denominator, and then you divide this in your head by that one, you get b, and you multiply b in the numerator, yes? And then you have minus, and this divided by that means 1, it becomes 1, and then multiply 1 in the numerator, so this becomes this. Okay, I don't know how, so how did you continue from here, Buel? Did you receive something like this in your calculation?
I factorized the numerator again.
Okay, so that's why. Because usually, again, that's a little bit of deviation. Usually we multiply and simplify and then factorize. But this is ready-made for us now, yes? So I can simply pull a plus b out. So then a plus b, I pull it out rather than, of course, this is not wrong. If you multiply, simplify, and then factorize, that's also possible. But this is ready-made for us now. So this is b minus a. And then there's also another point that I want you to remember, yes? So this is a good example of remembering, recalling many things for you, okay? So in this form, can I simplify these two? That is your mistake, I think, yes?
Yes.
Yeah. You cannot simplify exactly right away, because b minus a and a minus b are different. But we still, there isn't a way, yes?
And we factor out a
Minus sign. So that was the trick. Whenever you need a minus b, but you have this the other way around, remember this trick that you pull a minus sign out. I am pulling a minus sign. I could pull a minus sign out from this one, but I don't want to change it. I pull the minus sign from this one. I swap these, so this becomes a minus b, and then I have b times a plus b. And this a plus b and that a plus b are gone. If you want, I myself prefer to multiply it back, so it becomes a minus b. Instead of having this minus sign hanging over my head, I just multiply it back, it becomes b minus a over b. So this is the simplified version. I hope that you agree that this is quite a nice problem, because this complicated expression is nothing except that. Yes? Okay, of course the second one is a little bit harder, but now you have a little bit of experience. Try to combine all these experiences that you gained so far into one single problem, yes? Okay, so I want to wait a little bit for you to solve this problem as well. Is there any questions here? By the way, they are quite above the level of the book and even the national exam, so you really don't need to be worried about that, yes?
When you took the minus sign out, are you supposed to take it from both the denominator and the numerator?
No, because if you have a minus sign and then you have AB, this minus sign is either for the numerator or for the denominator, not both.
Then I have a follow-up question.
Yes?
Why did you change b times a minus b to b times a plus b?
May you repeat?
You changed b times a minus
Where
b.
you are talking about here?
Right there, and the next one, you changed the denominator.
Okay, okay. So no, that is my mistake. That's my mistake. Thank you very much for catching it. This awesome. That is my mistake. I don't know. So nobody told me this. Thank you very much. That was my mistake. I took minus sign out from here. So now this is the wrong simplification. Thank you. Thank you. Okay. Yeah. So do you see what was? I don't know why I changed this. I was confused probably. But the minus sign, I decided to pull it from the numerator. You could decide to pull it from the denominator, okay, but not both. Because if you have a minus sign here, this minus sign is either for the numerator alone or for the denominator alone. Yes? Okay, thank you very much. So now this a minus b actually cancels a minus b. And then this minus sign is there. So this is the final answer, minus a plus b over. So what was your question, Carl?
I was gonna say the same thing as Sim. I was confused about the last
Yeah, yeah, that was my mistake, sorry. Is that now understandable? So, and then it's better to keep the minus sign here. If you want, either you put minus sign here, or you multiply the minus sign into the whole numerator. So if you want to write, you can, I prefer to keep it in that form, but if you want, you can write it as a plus b divided by minus b, or you can write minus a plus b divided by b, which of course if you want, you can multiply the minus sign in. So this is correct, this is also correct, that one is also correct. Okay, so now I wait a little bit for you to solve the second one. No progress? Did you?
I did something, but I don't know if it's correct. What I did was that I multiplied the denominators.
No, multiplication of denominators become horrible.
Well,
Because I told you, of course, technically it is not wrong.
Yeah, well, okay, I processed the middle denominator.
Yes.
So that it became, what was it? It became 1 plus 2x and 1 minus 2x.
Yes.
Oh, yeah.
And then I took that number and I multiplied the whole bunch with it.
Yes.
Like all the numbers, and then so you can come here. So that's gone. So I multiplied.
No,
this
you
with
cannot multiply. This is a common mistake. Be careful. If you have this equal to something else, then you can multiply both sides. Be careful about this point.
Yeah.
You cannot take an expression and multiply it by something. Because if you take the expression and multiply it by something, you are changing the expression.
Alright.
Do you understand?
Mhm.
But if A is equal to B, if I multiply it by 5 and I multiply the other side by 5, equality still holds, even though the quantities has changed. So the logic of multiplying works if you have equality of two expressions.
Alright.
Yes? That is not working for the rational. It means that you are actually you are solving a different problem. You're getting rid of the denominators and solving that problem. Yes, they are not unrelated, because what you get is the numerator of the solution. I will give you an example that this will work actually, and that is if you want to solve equations. In that case, I would use your trick to multiply to be able to get rid of the fractions.
But in this case, it does not work.
No, that is. I mean, I want you to understand, not because I am saying it, because what you are saying is that you are multiplying to get rid of fractions, so you are changing the expression that you are supposed to simplify.
So in order for it to be what would you call it? For it to be correct, I would have to multiply the
And
numbers
divide.
back, divide. I would have to multiply and then divide again.
Again, yes,
Yeah.
that is correct.
Yeah, and
If your logic is this, then I would say that in these cases it is not that easy. But yes, in that case you are right. If you decide to multiply and remember that at the very end you have to divide again, then of course that is completely logical and correct. But how do you see the problem here? So, yes.
We have an answer, I guess.
So what's the answer?
2xb over 4x squared minus 1.
It's not
Okay.
that pretty.
What is your?
No.
Yeah?
I think it's probably incorrect, but 4x times ax plus 2b divided by 1 minus 2x, and then another parenthesis 1 plus 2x.
Okay, so let us see. I don't know. I don't have any clue. I need to calculate myself. But I remember that was some kind of a fashion in our time that they gave us a very, very big one and they simplified extensively. So, but let us see how it goes. Okay, so let us see how it goes. The first thing is that, can I simplify something here? No. Can I simplify something here? No. Here you can factor an x out, but don't bother to do that, because if you have experience from this problem, you might think that it's a good idea to factor x out. Yes, it is a good idea, might be, to factor x out, but there is no point for it because you cannot simplify, even if you factorize this. So that is what I want to say. But the problem is that the first thing, the first simplification, going vertically, simplifying vertically, does not work here. So there's only one way to take the common denominator. And for taking the common denominator, I told you that it is better to factorize everything. This is already in factorized form, so this is the expression that I want to factorize. Then you immediately realize there is a one small point there, yes? So if I factorize this, what is the factorization? It's 1 minus 2x, 1 plus 2x. So if I ask you what is the common denominator, what do you say? Yes?
2x minus 1, 2x plus
2x minus 1, 2x plus 1. And then what happens for the middle one, which is 1 minus 2x?
And you factorize minus 1.
Yes, so that's the trick. So this is important. If you insist to take the common denominator like this, you have to write this and that. But there is no point, because you see that this is 1 minus 2x, this is 2x minus 1. So let us just start writing it out. So the first one, I just copy and paste the first part, ax squared plus b. And then the second, 2x minus 1. But for the middle one, I realize that I want to have it in a different order. So I pull a minus sign out. Instead of putting the minus sign in the denominator, I put it here. So this becomes minus. The first one becomes 2x minus 1. The second one, it doesn't matter because this is addition. It doesn't matter if I write 1 plus 2x or 2x plus 1. So let me write it 2x plus 1. Okay, so be careful. This minus sign, I pulled it from here. And then I repeat. So I can multiply 2 in, by the way. So this becomes 2bx plus 2ax squared. Okay, and then I just repeat the second, the last one. Yes, so now it is completely ready to take the common denominator, and the common denominator, as you told, it's exactly 2x minus 1, 2x plus 1. But it was crucial to take this minus sign into account. Yes, is that clear now? Okay, now just repeat it. So you divide this common denominator by this in your head, this is left, you multiply this into the whole numerator. So it becomes 2x plus 1, ax squared plus b. Okay, and then this one divided by that one is 1, so I multiply the numerator by 1. But be careful, this minus sign that you pulled out, if you write it like this, then that becomes wrong. And by the way, in simplifications, these minus signs are actually crucial, because instead of getting simplified, they are actually adding together if you don't consider them. That is wrong. Yes? So if you want, so let me just write it like this, then I can remove it in the seconds. And then this divided by that is 2x minus 1, and I multiply there. But of course, there's a minus sign here as well, so this becomes minus 2x minus 1 multiplied by ax squared minus b. So to be honest, actually this is the only hard part, that you analyze the problem like this. But the numerator might be lengthy, but that is not hard. You just expand, yes? So this means that, yes? Yeah.
Oh yeah, no,
We just expanded that.
we thought we had to have done something wrong because it was such a lengthy.
No, it's not such a lengthy. This is 4 terms, 2 terms, 4 terms,
yeah.
yes? 10 terms is not a big deal, yes?
Yeah,
Okay. Yeah. Yeah, so So what you do, you just expand. So this becomes 2ax cubed plus 2xb plus ax squared plus b. I open up this pair of brackets and then multiply it by minus sign, so it becomes minus 2bx, but minus 2ax squared. Here I would prefer to do it in one step, but I have to be careful, because this minus sign is for the whole expression. So whenever you multiply, remember there is a minus sign that will come in the future. So when I multiply 2x by ax squared, it becomes 2ax cubed, but there is a minus sign coming later, so this becomes minus 2ax cubed. If you don't want to do it, you have to write a lot. Okay, for example, the next one, 2x times minus b is minus 2bx, but there is a minus sign coming later, so it becomes positive 2bx. And then again, minus 1 times this is minus ax squared, there is a minus sign coming in later, it becomes positive ax squared. And then you have minus 1 times minus b is positive b, but there is a minus sign coming in, so it becomes negative b. Yes? And then 2x minus 1 and 2x plus 1. So let us see how can we go for that. I think many of them will be simplified. Yes, for example, you see that 2x cubed minus 2x cubed are gone. And then, not that many, by the way.
No,
so
all of them
2bx and 2bx are gone.
No, all of them except. Wait, hold on a minute. What?
So might be I have done wrong, you mean?
No,
So because this b and that b are gone. Yes? Oh, okay, yes. ax squared plus ax squared is 2ax squared, but that's minus 2ax squared. That's also gone.
So we have two.
That's only 2bx.
Yeah.
Yes? So this is that your answer?
Yeah.
Yeah,
This
okay.
This is our answer.
That's good. So this becomes 2bx, and then divided by 2x minus 1 times 2x plus 1. Of course, if you stop here, that's okay. But I myself prefer, if this is simple, I just remove the pair of brackets by multiplying this back. This is not mandatory, of course. So this becomes 4x squared minus 1.
This wasn't minus.
So this is what we get. Yes? So it considered to be a hard problem at the level, but it is not really hard. It's a little bit lengthy. But is there?
To doubt yourself in the middle.
Yeah, yeah, but of course that is the point, because these minus signs and things like that, I have made a lot of mistakes like this before, but this you need to improve your skills, because calculational skills actually is a very important tool. Okay, so now you know how to do these things. Here is we have a mixture. So I have subtraction, addition, and then I want to multiply. Of course, in principle, you can take this multiplied by here, this multiplied by there, but this is not efficient at all. Okay? So how do you look at this problem? What is your strategy to tackle this problem? At least tell me something, then I will pause recording and wait for you.
The first part.
Yes?
Try to simplify each part.
And then multiply. So because pair of brackets means the priority is with this subtraction, this pair of brackets means the priority are with these, and then you have two new expressions and then using multiplication rule to multiply them. Okay? So this problem is a combination of addition, subtraction, and multiplication in one problem. Okay, I want to wait for you, because this is not something that you don't know how to do. I want to wait, okay? Okay, so let us see how this goes. By the way, this problem, just this part is very simple. So this is exactly at the level of the book, so you should be able to do it. So I will, as I told you, you can do them in parallel, but if that is hard, you really don't have to do it. You can solve this problem, but be careful about the final result. So let us just do it in 2 steps or more. So let us just take 1 plus x at a time over 1 minus x, and then minus 1 minus x, 1 plus x. So assume that this is the only problem given to you. So if you want to do it, what is the common denominator? Nothing can be done actually here. So just take the common denominator, here is the product. And then you divide this in your head by that one, it becomes 1 plus x. 1 plus x is supposed to be multiplied into the numerator, which is coincidentally the same. So this becomes 1 plus x to power 2. Minus, because of this minus. I repeat the process. I divide this in my head to this one, 1 minus x is left. 1 minus x is supposed to be multiplied into the numerator, which coincidentally again is the same factor. This becomes 1 minus x to power 2. Okay, let me know if you have problems here. Is that understandable for you? Yes? Okay, and then, as I told you, do not touch this for the time being. And then expand them. So this becomes the first one squared, 2 times the first one times the second one squared. You should be able to do it in one step. Otherwise, you have to do it in 2 steps. So I square it, but the minus sign is for all the terms that are supposed to come. So the first one squared is 1, a minus 1 will go later, a minus sign will go later, so it becomes minus 1. 2 times the first one times the second one is minus 2x, but there is also a minus sign coming later, so it becomes 2x. And then you have positive x squared, a minus sign will go later, it becomes minus x squared. And then you start simplification. So this positive 1, negative 1 are gone, positive x squared, negative x squared are gone. So what is left is 4x divided by 1 minus x, 1 plus x. In principle, if this problem was alone, I would prefer to multiply the denominators, but I don't do it right away because I know that later I'm supposed to multiply. So let us keep everything in factorized form. This is why I stopped there. But this one, another very simple problem. So I have 3 over 4x, and then I have plus x over 4, and then I have minus x.
Wait, what? I have a question.
Yes, please.
So if you didn't leave it at the factorized form, would it become more complicated to solve?
No, but because I don't know what is coming here, and because then I want to multiply. If you remember, for multiplication, then you have to factorize. So this means that I am multiplying here, but later I have to factorize it again. Yeah. So here, what is the common denominator? Can you tell me?
4x.
4x. What is the denominator of x which is not written? 1. So this is 4x, this is 4, this is 1. So the common denominator, so if you want, I can just imagine that there is a 1 here. So what happens, the common denominator is 4x. 4x divided by 4x 1 times 1 multiplied by its own numerator is 3. I have addition. 4x divided by 4 x times, and then x times that is how much? Is x squared. 4x divided by 1. 4x multiplied there, it's minus 4x squared. Am I right?
Yes.
Yeah. So actually, my prediction was not correct. Okay, so if you just multiply, it doesn't matter here. So it is 3 minus 3x squared divided by 4x. And then let me factor a 3 out. It's minus x squared over 4x. Now I realize it doesn't matter if you multiply. So now, because you see, I couldn't predict in the beginning, but now I realize this, if I multiply, it doesn't matter. But I don't multiply because that's a conjugate rule. So it becomes 1 minus x squared.
Well, then it does matter because you have to do it to simplify. It's not just positive.
Yes, but of course, now I mean that I am deviating a little bit about the logic. The logic that I told you is to factorize this. It doesn't matter here. So the question mark finally is equal to the first part multiplied by the second part. The first part is 4x divided by 1 minus x squared multiplied by what I got there. So it is 3, 1 minus x squared divided by 4x. It is not possible to simplify vertically, not possible. But in cross-manner way, we should also be able to simplify. And this is very simple now, because this 4x, whatever it is, will be cancelled by that one. And this 1 minus x squared will be cancelled with that one. So the final answer to this problem is just simply number 3. So So what does it mean? Can I say, let me just refresh your memory about what I said. Can I say that this expression is always equal to 3?
Yes.
No, be careful about this.
Unless
Unless there are 3 numbers that violate this. What are they? 0, because 0 cannot appear in this denominator, -1 and 1.
Yeah.
So except for these 3 numbers, it doesn't matter what I choose for x, the answer is always 3. But if I choose those particular values, of course, this is nonsense. Okay, any questions? Okay, so I want to wait a little bit for you to solve number 4. Do you have the answer?
Yes,
I will come to you. Just let me just. So in the meanwhile, I write one of the because now I see the problem there. I myself cannot resist to solve it. Okay, but I don't know if it's the right level. I will write it down here for you, and if you have finished this one, you can work on this. See how it goes. So x. So this is number 5. So x minus y over y minus a minus y minus a divided by x minus y, and then the whole expression divided by x minus y minus 1 divided by x minus y, and then minus x, no, y minus a minus 1 divided by y minus a. Yes. Yeah, the idea is probably similar to this one, but much harder. But if you have already done that, don't waste your time. Start working on this. I really don't know what will happen in solving this. So might be we need to do some factorizations that we haven't studied. I cannot promise that. Okay, but let us see how it goes.
what factorization haven't we studied?
Yeah, there are many factorization methods that we haven't studied unless you are following those videos. So, but I don't know how much factorization we need here to simplify it. Fine. Okay, but this I want to describe. Do you have any solutions for this, or you want to work more?
I have a solution.
So what's the answer?
1.
Just one? Okay. If that's just one, probably that's correct. Anyone else? Yeah, let us see how it goes. I want to solve it in 2 different ways. One fast way that I do it myself, and one the normal way. So what is the normal way? You calculate the numerator, because that, by the way, this is some skill that I want you to learn. It might be complicated, but the numerator itself is at the level of the book, and the denominator itself is also at the level of the book. So even if you cannot manage to solve all the problem, if there are 3 points for this problem, you can get 2 points easily because of solving the numerator and the denominator separately. Yeah, so don't just miss these things. So again, let me just do it again. In a not very efficient way, okay? So what I do, I just calculate the numerator, simplify the numerator. I hope that you realize that what is the common denominator is 1 plus x, 1 minus x, and then you take this 1 minus x goes there, and then plus x times 1 plus x. Do you agree with me? By the way, you can start solving the problem as before. You can simplify the numerator, keep it. You can simplify the denominator separately and keep it, and then divide the results. That's also possible. But I realize that I can do them in parallel, okay? So just confirm my calculations. Do you agree with that? So this is the common denominator. This divided by that is 1 minus x. I multiplied here. That divided by this is 1 plus x. I multiplied in the numerator. Okay, let me just do the denominator as well. So 1 minus x times 1 plus x is again the common denominator. So 1 divided by, so this expression divided by that is 1 plus x. I multiplied in the numerator, and then I have a negative sign. This divided by that is 1 minus x. I multiplied here. Yes? And then of course you need to simplify that. So let me just, by the way, if you are quick enough, you hopefully realize you can get rid of this with that. Yes? This is possible, but let us keep it. Okay, then I multiply this in. What happens? Let us do it in our head. X times 1 is positive x, which will be cancelled by this negative x. So 1 and x squared are the only terms that survive. And then I go to the denominator. I multiply minus x in. So it becomes minus x, positive x are gone, and minus times minus is positive x squared. And then your answer is correct, yes? Because you see that you have this expression divided by the same expression. Do you see that these two are exactly the same, unless the order here is different? But in multiplication, order doesn't matter. This answer is wrong. Yes?
How did you get 1 plus x squared?
I multiplied that, yes? So if in this case you have to expand that, it becomes 1 minus x. I multiply x in, and then this x and that x are cancelled. So the same thing for the denominator. But the most efficient way is actually more or less like what Asser said. But here I am actually rescaling. I am allowed to multiply now. Because if I have a fraction a over b, then I am allowed to multiply, for example, a by 5, provided that I do the same thing with the denominator. So in this case, that is the most efficient way. So what is the common denominator? Not just for the numerator. Of course, here it's coincidentally the same. So these are the denominators involved. So what I do, I multiply everything in my head by this. So I rescale everything by this factor. This is possible. And then do it in your head. You multiply this by that, this part are gone, so 1 minus x is left. And then I multiply this by that, 1 plus x, and then I multiply it like this. So you see? And in the denominator, I multiply this by this is gone, 1 plus x multiplied here. And then I multiply this by that, x is left, so I multiply it there. So you see, immediately I go from here to there. And then I expand that. So it becomes 1 minus x plus x squared, and then 1 plus x minus x plus x squared. And these two are gone, so this becomes 1 plus x squared divided by 1 plus x squared, which is just 1. Okay. So, because we don't have time, we have to finish a little bit earlier so that the new students arrive. So, but I want to do this one using this trick. Can you tell me what to do? I want to rescale it rather than going like a turtle, okay? We can just rescale it and do it a little bit faster. So what I want to see, this is more complicated than this one. Let me clean this off. We don't need that. Take it away. And then try to solve this problem. So what I do, I concentrate on all the denominators. Okay, but I am lucky because there are only 2 types of denominators. Y minus a, x minus y. And then I take the common, I find the least common multiple, not only for the numerator separately and denominator separately, but for all the fractions. But of course, in this case, I hope that you agree that least common multiple is just this. And then rescale everything by this, rather than going very slowly. But this is something that you can do it in your head. I multiply everything by this factor. But what happens if I multiply this by the first one? What will happen? This y minus a will be simplified with this y minus a. X minus y will survive, which will be multiplied in this numerator, which coincidentally is the same. So you see, you can do it much faster. Yes? And then minus, again, you multiply this by this fraction, x minus y in the denominator will be cancelled, that one. This will be left, which is supposed to be multiplied in the numerator, again, coincidentally the same. So as simple as that. So we just got rid of all those things, we just wrote this. And in the denominator, what will happen? Can you tell me? What will happen in the denominator?
Just become x minus y.
Y multiplied by? No, so no, here.
Yeah, yes, we can. Yeah,
So this x minus y will be cancelled by this x minus y.
yeah.
Y minus a will survive, which is supposed to be multiplied by the numerator of that particular fraction.
Yeah.
So this becomes y minus a, x minus y minus 1. And then I have a negative sign. And then what happens? This will be simplified by that. X minus y survives, which is supposed to be multiplied in the corresponding numerator. So this becomes x minus y multiplied by y minus a minus 1. At least I got rid of those horrible fractions where I'm just having one single fraction. And now we know what to do. In order to simplify a single fraction, there is no way unless to factorize the numerator and the denominator. Here, what do you suggest to factorize the numerator? Of course, you can expand and factorize. But this is already in the conjugate pattern form. Yes? If you consider this is your box and this is your circle, then that is the conjugate rule. Yes? So the answer to the numerator, x minus y to the power of 2, y minus a to power 2, can be written as the square root of the first one minus the square root of the second one multiplied by the square root of the first one plus square root of the second. Understandable? So that is the factorization. So you see, you have to be observant if you want to do things efficiently. Of course, you can raise it to power 2 and then think about factorization. But this is already ready-made for you here. So I just factorize it. But of course, I will not stop here because I always care about simplification. So I remove these pair of brackets so it becomes x minus y and then minus y plus a. And this one becomes x minus y plus y minus a. And then I am lucky because this is gone. So this is x minus a left. And unfortunately, this is not gone. So, but I have to live with it, okay? Anyway, so I know the numerator. So the numerator I already solved in the factorized form. It is x minus 2y plus a and then times x minus a. But there is no way that I can see. We have to be patient and expand, simplify to see if we can factorize. And this I don't know if we can really factorize it right now. But let us try to do it. So if I want to factorize it, so I want to go to the denominator. So d for denominator, okay? So let us just expand that in our head. Y times this minus y squared minus y minus ax plus ay plus y plus a. This is the expansion. And now the second one, be careful. You multiply, but there is a negative sign that is belonging to all the terms. So let us just do it in one go. So x times y minus, it becomes minus xy. Minus ax in the future becomes positive ax. Minus x becomes positive x. Minus y squared becomes positive y squared. Positive ya becomes negative ya. In positive y becomes negative y. That's the denominator. Yes? And then try to simplify it. So for example, I immediately see that these two are gone. These two are also gone. Okay, very good. That is also gone. Oh, even more than that. But that is also gone. So what is left then?
Y.
Minus y.
Okay, x minus 2y plus a. Exactly that factor. Yes? So that's very simple actually. So that's it. It was not hard at all. So there is nothing involved in factorization or something. So here it is x minus y from here minus y from there. It's just minus 2y. And then this a is left alone. So it's done. So the whole expression, the question mark, the numerator is x minus 2y plus a multiplied by x minus a. And then I divide it by the denominator, which was this one. And then I am lucky enough that these two are exactly the same. So this expression is just simply x minus a. Yes? Okay. Any questions? Let us write one more and then do it together immediately, so because there's no time that I wait for you. So what do you think about this? I don't know. Let me just write x over y minus y over x, and then this is supposed to be multiplied by x over y plus y over x minus 2 to power minus 1, and then you are supposed to multiply it by this expression 1 plus y over x multiplied by x over x minus y, and then to power minus 1. Okay, so how do you solve this problem?
Probably begin by like because the to the power of -1 that just means
If you have a fraction a over b, when you say to power minus 1, what does it mean?
we flip the
It becomes b over a. Why? Because any number to a negative power means 1 over a over b to the power of positive 1. So this becomes the inverse of a over b, which is, as you said, b over a. So this is, remember this, if you have a fraction and then to a negative power, by the way, you can have it like this, a over b to any negative number n. If you flip, then the price that you need to pay is to get, actually this is not the price, that's just the reward that you get. You get rid of that minus sign. Okay, so if you want to do it, let us just do it efficiently. So here, can you just immediately see that I can take the common denominator, x goes here, y goes there. Is that understandable? So if I do it quickly, can you follow? That is exactly this. But here, be careful. Am I allowed to flip these now? No, because this is a sum. Only it works for a product. So what I have to do, so I have to be patient a little bit here. Put this minus sign and just do the calculation here. So what's the calculation here? The denominator here is 1. The common denominator is again xy. This divided by that is x times. I multiply it there, it becomes x squared. This divided by that y times. I multiply it, it becomes y squared. The denominator here is 1. xy will be multiplied there. But here I have a power of minus 1 on top of that, but I have some products going on here. So I can simplify this. The denominator here is 1, the common denominator is x goes there, and then plus y. Are you following? And this expression is exactly this, yes? So this is might be a hard problem, but it actually is including a lot of very simple problems. But here, this is already in simplified form, but what is the operation between them? That is product. So everything is here. Oh. Yes? And now what can I do? Here, I can factorize it. Here, I have a minus sign. And this is one single fraction. So this rule actually applies. So I can flip them, and then it becomes positive 1, but I don't need to bother to write positive 1. So this becomes x over y, and then you recognize this pattern now, yes? This is x minus y to power 2. But here, I am supposed to multiply this fraction by that fraction, x and x are gone. X plus y over x minus y is left, but there is a minus sign, so I flip them. So it becomes x minus y, x plus y. Yes? And now everything is very simple, yes? Because xy and xy are gone. This xy from here will be cancelled with that x plus y. X minus y, one of them, and the other one of them. So the answer is again 1. Yes? so hopefully now you have enough experience to solve problems like this harder level. Any questions? But as I told you that they are completely above the questions in the book, so if you don't like them, you really don't have to learn them that much. So don't worry about those. But the problems in the book, that is something that you need to know very well. Any questions? Okay, thank you very much.